Here we are at our example 6 from our 8.47 notes. We're asked to multiply the following rational expression. Now, in looking at this, what we're going to go ahead and do first is factor this top left piece. We're going to factor out everything, but we'll start off with this top left item. And when we factor that down, we end up with 2x times 2x gives us 4x squared. Looks like our other factors that we have to use are 3 and 1. And we'll just say 3 is here and 1 is here. And we're trying to aim for negative 4x. So if we make this one negative, that would give us negative 6x. If we make this one positive, that would give us positive 2x. Then that gives us our negative 4x that we're looking for. So again, you can check this by just simply distributing all the items, and it will get that original statement. On the bottom, this bottom left one, we notice that we can go ahead and pull a 2 out of both pieces, as well as x squareds out of both pieces. So 2x squared we can remove. And when we do that, when we pull that 2x squared out of this piece, we're only left with x. And when we pull that 2x squared out of the second piece, we're left with minus 5. So that takes care of the left rational expression. Let's go ahead and focus now on the right. In fact, also we'll just go ahead and change that multiply symbol to a big dot, not to confuse it with an x. Factoring this top right item, it looks like we can pull an x out of each item. So we would be left then with 2x squared minus 7x minus 15. On the bottom, we are left with a difference of 2 perfect squares. And so that factors out to be 2x plus 3 times 2x minus 3. Now, unfortunately, we're not completely factored out. This top right item can be broken down further. I just didn't want to do 3 different types of factoring all at once. Maybe lose some people. So we would end up then with 2x plus 1, pretty much just rewriting most of this as 2x minus 3 all over 2x squared times x minus 5 times x is still on the outside. And then breaking this down, 2 things that multiply to 2x squared would be 2x and x. Again, breaking down this trinomial into 2 different binomials being multiplied together. The last number is 15. So looking at, factors of 15, 5 and 3 usually come to mind. So maybe we'll put a 5 here and a 3 here. When we do that, we end up with 10x and 3x. Well, that can combine to give us 7. Or negative 7 if you want to look at it that way, negative 7x. And we would then have to have more negatives, so the 10x would have to be negative. So again, this 2x times negative 5 would give us that negative 10x. And then if we made this 3 positive 3, we would end up with plus 3x, giving us then a combination of negative 7x. So this factored out to be this piece. On the bottom, we still have our 2x plus 3 times 2x minus 3. And one quick little strategy, if you're ever kind of in that scenario and you're not certain maybe what to factor this out, maybe look around, like for example the bottom. Hopefully there should be like a 2x plus 3 or a 2x minus 3 as a factor, because a lot of these problems are kind of structured where something will at least drop out. And in fact, we can actually see that right here, that 2x plus 3 will end up canceling out. Now when we do that, we end up with these 2 dropping. Looks like the 2x minus 3s can drop out as well. And even the x minus 5 can drop out because we are again multiplying that. And so As a result, it looks like we end up then with 2x plus 1 times x over 2x squared. And we can actually even break this down further. We notice that we have an x on the top and x squared on the bottom, so we can actually remove one of these x's. So instead we'd have just x to the first now. So then it looks like our final simplified version comes out to be 2x plus 1 divided by 2x. Again, we could have done that earlier, so like right here. But again, I don't want to cross off too many things and maybe miss some people. One thing that I have seen in the past, a kind of common pitfall, if you want to think of it as that, is right here where we see a 2x squared and on top and a 2x squared on the bottom. And some people have seen this in the past, at least. Not a great deal, but enough to mention, where students will cancel those out. So they'll try and drop this as well as that. And unfortunately, it's a very common, kind of mistake. But we do have to consider this 2x squared piece is part of an entire set. That includes the negative 7x and the negative 15. And that's why parentheses around these are so important. Because it really distinguishes what is part of the set and what goes with other values. So again, just kind of avoid that if you can. But again, though, this is our simplified version for example 6 from our 8.4 set of notes.